of today, computers, it is one of the most important instruments of humanity. History, I never thought that I would be part of computer history. I never thought I would be part of history. I take my work very seriously, as all of my colleagues in NVIDIA will tell you, but I don't take myself seriously. And that's kind of the reason why I said, what am I doing here? I'm nobody. And in a lot of ways, it makes no sense to me to be part of history. And surely makes no sense that I'm in a museum. It really is too soon. We started the company with the idea that we would reinvent the personal computer. The personal computer in 1993 was still basically nowhere. Windows 95, which is probably the single most important computer product, mainstream computer product ever created, hadn't obviously been introduced. Our idea was that we would reimagine, reinvent the personal computer when it does come, and give it the capabilities that we otherwise saw in supercomputers, and provide mainstream computer graphics that were so good that you could use it for things like video games and all of the other things that we now take for granted. We imagined reinventing the computer. In 1999, as Mark was saying earlier, we introduced the GPU. The GPU, by the way, is the first other processor in a computer that's programmable by software. That had never happened before. And that introduction of the GPU, a programmable chip, aside from the microprocessor, was controversial, it was dangerous, but we felt that someday there would be another type of computing device or another way of doing computing. We imagined accelerated computing that could revolutionize the computer. In 2006, we introduced CUDA, which made the graphics processor programmable into something a lot more general purpose. CUDA was our vision for turning NVIDIA into a computing platform company. In order to be a computing platform company, there is simply one law: install base. There's only one type of successful computing platform, something with a large enough install base. But install base is impossible to achieve without applications, and applications are impossible to achieve without install base. This chicken egg problem confronted us since the very beginning. But we believed in what we were trying to do, and probably the second great idea that the company came up with was not CUDA. CUDA is technology. The second great idea was suffering. That we would dedicate ourselves to the end to make CUDA successful and to expand its install base until an application found it. And so we put CUDA into every single GPU of ours. It cost our company about 20% of our gross margins. NVIDIA, you know what NVIDIA's market value is today, but taking CUDA to market drove our market cap, and as Mark Stevens will remember, down to about $1.5 billion. It was so low that an investor in Japan reached out to me and asked me if I wanted to buy the company with my own. He could just lend me some pocket change, and I would buy the company, and then I would be the only shareholder. I declined the opportunity. I regret that, but I declined it. That was Masa-san. And he told the story just last week. In 2012, CUDA found the killer app. We kept CUDA on all of our GPUs until one day some students in the University of Toronto some students in New York University and some students at Stanford University discovered CUDA in order to try to attempt to win AlexNet. And that day was a big day for us because all of a sudden we discovered this new algorithm. But we discovered this new algorithm like everybody else discovers a new algorithm. Everybody else saw AlexNet. I saw AlexNet, the paper came out, AlexNet, it was an incredible achievement in computer vision. But the third great decision the company made was recognizing that AlexNet wasn't just an extraordinary computer vision breakthrough, that it was a fundamentally new way of doing software. From human coding, it was machine learning. My observation was, what did Alex know about computer vision? It turned out he didn't know very much about computer vision, but he was able to develop an AI that did computer vision better than any algorithm any human ever wrote. And that observation led us to think, what would happen if machine learning or deep learning were to continue to expand and to apply to all kinds of new applications? And we decided that day, and over the course of about several years, some close to 6 years or so, to completely reinvent everything in our company, so that we re-engineered every single layer of the computing stack. Instead of software, human-coded software running on CPUs, we would create machine learning software, or otherwise coded as neural networks, that ran on GPUs. And in, I guess it was 2016, yeah, that's right, 2016, we introduced a brand new computer the world's never seen before. It looked different, it weighed different, it was much heavier than any computer in the past, and we called it the DGX-1. And on the day that I announced it, NVIDIA was the only customer. No one asked to buy it, nobody knew anything about it, and I built it for our own software development team. And fortunately, I had a friend on stage at that announcement, and his name was Elon Musk. And Elon said, "I need one of those." And I was thinking, my first thought was, I might be able to sell one. And then he then told me that he had started this company called OpenAI, but it is a not-for-profit company. And so all of the hopes of revenues left, and I delivered anyhow the world's second DGX-1 to OpenAI, and the rest of it is history. Several years later, they introduced ChatGPT, and it sparked the idea of artificial intelligence. And we've completely changed how computing is done, from coding to machine learning, from CPUs to GPUs, from software to artificial intelligence. Now, we all know that artificial intelligence is increasing at an extraordinary rate. We all know that the ability to automate intelligence, a capability we felt was solely the capability of humans, the unique capability of humans, is now produced by computers. All of that we're confronted, and in an extraordinary thing that for the very first time in history we can imagine accelerating the discovery of solutions for some of the most daunting challenges. Climate change, life-saving drugs, dealing with workforce reduction, solving inflation. For the very first time in history, we have technology that we can do that with. But at the industrial level, it is far more profound. What is extraordinary is, just as in 1995, Microsoft invented something very new. If you reflect on it, you realize. And you might have heard Bill talk about Microsoft in the early days. that Microsoft wasn't just an operating system company, it was a software manufacturing company, that they were going to manufacture software at scale, that they were going to produce software of all kinds, that we would have for the very first time to produce something, an industry that produced something that is invisible, that you can copy easily, and that it would be trillions of dollars in scale. Well, for the very first time, we are now manufacturing this invisible thing called intelligence. We're manufacturing it right now as we speak. We have factories all over the world. They're running 24/7. They're producing this invisible thing called tokens. These tokens are constituted into intelligence of different kinds. We can generate intelligence as 300 years ago we could generate electricity. We are now generating intelligence in scale. The size of this industry, the technology industry, the computer industry that we're all part of, made this possible. The manufacturing of intelligence finally. And it is an extraordinary time. We're going to have all kinds of things. You know, I use AI every single day. I use it as an AI tutor. Of course, we'll have AI doctors, AI software engineers, AI chip engineers. The next 10 years we're not going to want to miss. The next 10 years we're not going to want to miss. I've had the privilege of the computer industry being my life's work. And I've had the privilege of standing on the shoulders of the amazing people that were honored before me. Our heroes. In fact, NVIDIA's latest generation processor is called Grace Hopper. 2 processors. 2 processors, one called Grace and the other one called Hopper. NVIDIA wouldn't be possible if not for Mead and Conway. In fact, there are many people I see in the audience. Our industries literally would not be possible without Mead and Conway. And of course, Moore's Law. This idea that we can drive technology at the rate that we have. And of course, today, the compounded benefits of semiconductor physics and processor design and artificial intelligence is making it possible for us to move at hyper Moore's Law. There's so much, and of course, the surprise video from Morris Chang, somebody that I've worked with for a very, very long time and admired for a very long time. I interviewed him here for his fellow award. And so I look forward to the next decade. I want to thank all of you for this incredible honor. And as Jake said, they built it, she built it, and it's our job to manage it. Now we have a new fabric, a new layer on top of the internet. And this new layer on top of the internet is called intelligence. And it's our job to build it and manage it. And then there's one thing I wanted to say. There's so much wisdom that Steve passed. I was jotting it down. And what did hang on a second. What did Nolan say? Can't do anything if you're dead. You know, everybody's got philosophies. I got some of my own. And mine is you have to run, not walk. You have to run for food, or you're probably food. That's So I want to thank all of you for being here tonight and for this incredible work.